Okay. There we go. Thank you very much, Andy. Andy Gray from CDT, he's doing this the presentation for us today. So you are free to fire away. Thanks, Andy.
Thank you, Heidi. So hi, I'm Andy. I'm a CDT student from cohort 2, and this is the MSc project that I recently just completed and done a presentation on. So the MSc project I done was Rate My Tweet, Comparative Judgment in the Wild. And this was in partnership then with my stakeholder, who is CDSM. So today we'll look at the motivation, the background, the methodology, the implementation, the results, and then the conclusion of what I found within my study. So the motivation. So for many years before coming on to the CDT course, I was being involved in some form of educational setting. Majority of these has been as a sixth form and a secondary school teacher. And I kind of, when I entered the profession, I felt like, oh, actually, a lot of the time is going to be spent making these amazing lessons to get all these students involved and learning and really engage with what they're doing. However, I quickly found that most of the time we were actually just generating reports and just doing admin stuff that really wasn't then allowing us to focus on what was needed, which was making these lessons for the students. So the motivation for this project then was to be able to create a tool for educators that will empower them, allowing the technology to do what it's good at and aiding the teachers in their decision making to allow the teachers to focus on what they're good at, which is creating and delivering lessons to shape future generations. So the background to this project then was looking at 3 key focus areas. The first area was the role of marking and feedback within teaching and learning. The second one then was comparative judgment and what it can do. And then the third one then is other types of ranking systems that are potentially available to us. So marking and feedback. Educators conducting marking and feedback provides multiple benefits, not only to the teachers, but to the students as well. It provides a means to assess the students. That's through diagnostics, which is also known as baseline testing. So there's ability for the teachers to be able to see, well, what level is that student coming in at, so they know, well, where they need to then try and take them to. You've got formative assessment then, which is also referred to as assessment for learning, which is also abbreviated to AFL, and this is more to do with the kind of the questioning and answering within lessons, or like marking the book at the end of a lesson to provide that feedback. Or you've got then the other type then, which is summative, which is more about like end of unit tests, and it's more kind of like a cap of how they kind of like an overview of how they've done over that particular subject, for example. So it also gives the teacher the ability to rank the students and give them specific grades that fall within those rankings, and ultimately provide the feedback. And by doing this, this provides then the students to be empowered with knowing, well, what they've done well, but then ultimately what they need to do in order to improve, because ultimately we want our students to keep on improving. But it does draw multiple, has multiple drawbacks. One of them then being that the feedback's only helpful if the students get a chance to act on it. So for example, if you're doing a formative and you mark in a book, but then the students don't get the chance to then review that feedback to make those changes to their work, then that feedback sort of means nothing. It's more of just a summative task then. Marking also creates a huge cognitive load for the teacher. So trying to be able to, in that moment, be fair and equal and absolutely mark that piece of work is such a burden for a teacher, and it's quite a draining task. And then to have to do that for 30, maybe more students and stuff per class, it's quite a big task for a teacher, which then ultimately leads in them to making that, it makes it hard for a teacher to remain unbiased. So where a teacher tries to mark stuff anonymously, they will naturally know, oh, this is this student and they were very good through the year, so I'm going to be a bit generous through it because they've just done badly here. But then this student maybe has been a bit of a pain, but I'm going to mark them down kind of thing, but then ultimately not really taking into face value how that student done within that test there and then, really. And then obviously, ultimately, marking requires a lot of time, which then usually results in the teacher marking it over a couple of like different sessions, which then again, it kind of makes it harder to remain completely equal within the style of marking, because different moods, different times, different tiredness and all that kind of stuff. So this brought on comparative judgment, and comparative judgment then was introduced in 1927 by Louis Leon Thurston, and what he found out was that the humans are very good at pairwise comparisons, so they can very much figure out like, oh, this phone is heavier than this pen. This mouse is lighter than this phone, but then it's heavier than this pen. And so if he figured out that the human brain is very good at these pairwise comparisons. However, within the educational space, an approach called adaptive comparative judgment has been adopted. And this at the core is the comparative judgment process. But the main difference from this is where comparative judgment requires every physical combination taking place and then comparing it and then ranking it that way. Adaptive comparative judgment has more of a method of what's referred to as rounds, which is the number of cycles the marking goes through, and then judges, which is your markers. So depending on the judges and the number of work will dictate how many rounds that are potentially needed. And what happens is they'll go through a first round and sort of rank the students, and then they'll go through multiple rounds and then adaptively changing the students that are very close to each other within their rankings to then ask the teachers more to figure out, well, which one is actually better than the other, and then create a more defined kind of like ranking within the students' work. And the studies have found out that this is actually it has very high accuracy rates. However, again, this has multiple flaws. One of them is the actual process increases the workload. So while it does take away the cognitive load process that is taken within marking, it does actually increase the length of time. For example, studies found that if you're just doing a typical rubric style marking of a piece of work, that actually ends up being quicker than the entire adaptive process. Another issue with this is it doesn't provide any feedback whatsoever to the students. So again, adding to the workload, because not only will it rank it, but then the teachers have to go in and figure out, well, why has it ranked it for that? And what are the things I need to extract to then give that feedback to that student? And ironically enough, the whole process is trying to remove bias from it, like, you know, from the teacher's kind of mark, but then the process itself causes bias due to its adaptive nature, because it's already showing the sort of similar ones in the middle more. This then kind of creates an unintentional bias within then the rankings. And ultimately studies found that the results accuracy is actually not much accurate through this adaptive process than if it was just to have random pairings of them and ask people which one is better. So this led us on then to, like, you know, kind of look into other systems that could help do this ranking process for us. Sorry, was somebody going to ask a question? No, okay. So we've got ELO and the glyco system. So the glyco system then was created by Arpad Erlo in the 1960s, and it was first introduced by the United States Chess Federation as its main method of ranking in the 1980s. However, it does have some flaws, which is, for example, players protecting their rating, selective pairing, and then ratings inflation and deflation. So Glyco then was created by Mark Glycoman, and it's very similar to the ELO system, but the reason why he produced it was to address the flaws within the ELO system. And how he got about this then was to create an RD measure, which increases over time within activity. So what we aimed to create then, okay, was ultimately we wanted to reduce the cognitive load for the teachers while also reducing the workload. So how we went about trying to achieve this was we created a web app, which then would allow the teachers to be able to get 2 tweets given to them, and they were asked to pick out of these 2 tweets which tweet they found funnier. And the topics around the tweets was to do with Brexit, so that we had that one topic range, so that all the kind of jokes would be in a similar area, so it's easier to sort of compare against which one you thought was funnier. However, in order to reduce that workload, we ensured that the teacher or the marker only saw 1 tweet. So for example, there was 10 tweets used. Instead of them seeing tweet 1 9 other times, and then it loses sort of impact against them, we made sure that they only saw that tweet 1 once. And what that allowed then is taking the full combinations, which would have been 49 different combinations, reducing it just down to 5 different combinations. And the idea then was through the crowdsourcing method, we then get that overall ranking, which then they would then, through them picking who they thought was the funnier tweet out of the 2. And as I sort of just said, then we would create a ranking. And the idea then was to try and take those findings that we had, put them into some NLP processes to hopefully give that feedback to the user on why this might have been the case. So these are the tweets that we used. I'm not going to read through them now, but they're there for you to have a quick little look through. And what we ended up using then was a couple of different ranking systems just to see how efficient they were against each other. So the first one we used then was the ELO system. And the reason why we used this was because actually the issues that you get with the ELO system, the way that we were implementing the system wasn't actually anything that they wouldn't have been effective. So they wouldn't have been effective results at all. So we were able to like reduce the kind of, we provided random pairings, so you couldn't select who was going against it. We obviously managed to remove the idea of protecting the ratings, because it doesn't matter, because it's all happening random and stuff. So how the ELO score works is that it's broken into 2 steps. The first step looks at the probability that tweet A would win over tweet B. And how this is done then is by taking, figuring out this calculation here, okay? And then the second stage then is taking that, like, you know, that expected score result, and then we then figure out if the tweet won or not. So if the tweet won, the score value here will become 1. If it loses, it'll be 0. And then we take away then the result from this then, and then we multiply it then against then the current rating plus 32. And that then generates the new score for the player, or the tweet, should we say in this case. We then used a very simplistic comparative judgment score, which was just looking at the number of wins that tweet had minus the number of losses. And then we looked at a T ranking score then, which is just a basic weighted sum method, which was just looking at that tweet, how it done within Twitter. And it was looking at the number of retweets that tweet had and the number of likes divided by the original tweeter's number of followers, and that gave us the T rating. We were aware that there was probably better methods to use out there, but for the scope of this experiment, we thought that this simplistic more approach will probably be suffice. So in terms of NLP then, we tried to do some information extraction. And what we used for that was a couple of techniques called part of speech or pause tagging, named entity recognition, NER, feature extraction, sentiment analysis, text similarity scoring, utterance pattern matching, finding word sequence patterns, and then key phrases. So the implementation we made then, so this was the final website we made, where you've got like a welcome screen here where people can go in and kind of navigate through the different areas. It did require a log up to generate the back end for everything, but then once the users logged in, this is sort of what they would see, with the opportunity, the 2 tweets presented to them, a little bit of gamification with the times of the progress bar and like the kind of live update, and this ability to provide feedback. We made this optional so that, because we wanted people to give actual meaningful feedback rather than just like bashing at the keyboard if it was made kind of that they have to do something about it. Then we've got this section that explains what comparative judgment is and how it works. We've got then a results page which updates live to give the ELO results and the comparative judgment scores. And then we had a bit of a feedback if anybody wanted to give feedback. So this is available for you if you wanted to see it right now on the internet through using this link here, okay? Excuse me. So the results. So overall, 40 users took part in the experiment, and all the tweets were used within them. So every possible tweet combination got seen by at least one person. So we found out that tweet 1 versus tweet 5 and tweet 7 and tweet 9 were the highest occurring tweet combinations that happened, and then tweet 6 and 7 appeared the least. But then when we look at the results and the wins percentage and the amounts that they won, we found that 10 tweet comparison results in the same tweet winning 100%, which is also reflective within the results, where these particular tweets were way, way higher than the other ones. Tweet 4 beat tweet 2, for example, the most of 6 times to 1. However, tweets 2, 5, 6, 7, and 10 had moments where they didn't win a certain tweet against a certain tweet at all, while tweets 2, 5, 6, 7, and 10 didn't win against any, at least 2 tweets, okay? So the results then, so when we look at the ELO versus the CJ, we can see that these are very positively correlated. So the numbers, the colors represent the tweet IDs. So you can sort of see how they've done compared to comparative judgment and then the ELO scores. The Pearson scores themselves then was a positive rating of 0.98. So I'm going to just round it up to that bit so we don't have so much precision. While the T ranking then, however, we noticed wasn't very correlated at all, and in fact negative correlated, and they didn't really match up at all. So sort of showing us that the results that we got in this kind of experiment didn't match up to the real world, what happened in Twitter, kind of showing that maybe just because something is more funnier doesn't necessarily mean it gets the traction. It could be like multiple factors at play. Also, just because Twitter's a global thing, maybe it's to do with the fact that you know, people from France will see Brexit in a different light to people in maybe like obviously England or America and so on like that. But when we done the Pearson's test to it, we found that the ELO was actually minus 0.14, and then the CJ was minus minus 0.1, rounding that up. So when we look at the results, we can see that the ELO and the CJ rankings generated very similar results, and that demonstrating that the ELO could handle the random pairing well. And also tweets coming in 6th, 7th, and 8th were slightly varied, but this was more to do in terms of the CJ, where you maybe had, like, for example, 2 tweets with the same score, which then there was no extra factor to differentiate between the two of them. So it ended up just kind of like putting, you know, the order of which ones that they came in then. So for example, tweet 2 is higher than tweet 5, purely because tweet 2 comes first. Sort of showing again a bit more of the robustness nature of the ELO system with that more exact scoring. However, ELO against the T ranking is very different. What came first in the T ranking came 4th in the ELO ranking, and then what came first in the ELO ranking came 8th in the T ranking. And funnily enough, 4 of the top 5 T ranking tweets were actually in the bottom 5 of the ELO ranking within our experiment. So when we look at the NLP results, then we can see that we were able to do text similarities between the named entity recognitions and also the text overall. So when we looked at just the NERs with the named entity recognitions, we could see that tweet 3 and tweet 4 were the same based on their tags of Britain, EU, and then obviously UK, EU, and then these are the tweets here. But when we looked at the entire document itself, tweet 5 and tweet 10 were the most similar, and then these are the jokes there. So you can see that they're quite similar style in jokes, which I thought was quite interesting to see that the system was able to pick that up. In terms of the sentiment analysis, 6 of the sentiment scores was classified as positive, where 4 of them was negative. What was also quite interesting is that 5 out of those 6 were in the top 5 of the positive ones. So kind of giving the feedback that, like, you know, if a text is more positive, it's more likely to be perceived as funnier. Also, the key phrases provided some good insights, apart from tweet 7, where it just said Brexit was, that sort of didn't really provide that much information, but the others had quite good actual summaries of what the tweets were. The pause tags and the named entity recognition provided some good insights. And then the other 3 techniques then provided no meaningful insights at all. So sort of showing us that the NLP stuff had some promise, but it needs a lot more work really to be the kind of tool that we need. So just to conclude then, overall, the ELO system seems like a good alternative to the comparative judgment, but a bit more study needs to be done to see how well it handles it. The ELO system then was able to handle the element of random pairing well. Both the ELO and the comparative judgment scores were positively correlated. The ELO system was able to remove the need for multiple judging rounds. And then obviously the T ranking was negatively correlated to both the ELO and the CJ scores, sort of showing that real world stuff and that kind of things didn't really match up to what was happening within this. And then the NLP created some good building blocks, but no meaningful feedback at present. So future work then would be a bigger sample pool to conduct the study on to see the ELO's effects. Ideally converting the ELO scores results to a grade mark. For example, like, you know, if somebody has a ELO score of 1,700, that could convert to like a GCSE grade of an A, or like 1,500 and that being a B, and so on like that. And ultimately exploring the NLP capabilities more in providing personalized feedback and then allowing the feedback to be generated automatically. And what I mean by that is currently the implementation of this then is that it's all kind of just run through this script where we're just giving all the feedback to the user in terms like the pause tagging and then the named entity and stuff like that. So it's making that more integrated within the application itself then. And then that brings us to the end of the chat. Thank you very much. And any questions?